Hey friends, in this series of ECG Basics, today I will talk about ECG rate interpretation. First is the disclaimer. Caring Doc's YouTube channel does not provide medical advice. Information available on this channel does not offer diagnosis or advice regarding the treatment. Information provided by this channel is for educational purpose. It should not be used as an alternative to healthcare professionals' diagnosis or treatment of any person or animal. Please seek the help of medical expert for diagnosis, prevention and treatment of medical illnesses. There is no endorsement for any brand or a company. Before calculating the heart rate, we have to remember that the ECG paper, the standard output for the ECG paper is 25 millimeter per second. If different paper speed is used, then the rate calculation will have to be modified appropriately. Whenever the standard paper speed is 25 millimeter per second, then one small square, that is 1 mm, is equal to 0.04 second, or when we can say 40 milliseconds. 5 small squares are comprised one large square, which is equal to zero point 0.2 second, and 5 large squares are equal to 1 second. At a standard paper speed of 25 millimeter per second, the rhythm strip consists of 200 small square, which are equal to 50 large square, which is equal to 10 seconds. So before calculating the rate in beats per minute, we should understand that a rhythm strip, if it is recorded for 1 minute, it will comprise of 1500 small square, 300 large square, that will be equal to 1 minute. For calculating the heart rate, we usually use three methods: large scale method, small scale method, and R wave method. First is the large scale method. Here we recall the above 300 large scale is equal to 1 minute at a paper speed of 25 millimeter per second. We can thus calculate heart rate by dividing the 300 by number of large square between each RR interval, that is the space between the two consecutive R waves, that is one beat. For example, two large square between each RR interval, they will imply a rate of 150 beats per minute, 3 will imply a rate of 100 beats per minute, and so on. So in large scale method, we usually divide 300 by number of large square between the RR interval, and it is useful for regular rhythms. If large square between the RR interval are 1, then the heart rate will be 300. If two large square are there between the two R waves, the heart rate will be 150 beats per minute. If three large square between RR, then the heart rate will be 300 divided by 3, that is 100 beats per minute, and so on. In small scale method, it is same as that of large scale. Here we divide 1500 by number of small square between the two consecutive R waves. For example, when there are 10 small square between the RR interval, it implies a heart rate of 150 beats per minute. When they are 15, then it implies the rate of 100 beats per minute. So in this we divide 1500 by number of small square between the RR interval. It is useful for very fast regular rhythms as it provides more accurate rate than the large scale method. Third is the R wave method. Here the rate is calculated by number of R waves in a rhythm strip, multiply it by 6. So the number of complexes, that is count the R waves on the rhythm strips, gives the average rate of over 10-second math period. This is multiplied by 6. 10 seconds means 10 seconds into 6 will give us 1 minute to give the average beats per minute. It is useful for slow or irregular method. As we know that 1 second is 5 as we know that 1 second is equal to 5 large scales. So in 10 seconds we will have 50 large scale. We will calculate the R wave in those 50 large scale, and we will calculate those we will multiply those R waves which are calculated in 50 large scale by 6. uh, we have to multiply those uh, R waves in 50 large scale with 6, then we will get the heart rate. It is useful for slow and irregular rhythms. And always remember that whenever there is a complete heart block, we usually calculate the atrial and the ventricular rates separately. The machine reading can also be used to calculate the heart rate as it depicts, but at times it can be inaccurate in the presence of abnormal QRS or T wave morphology. For example, it may count the peaked T waves as QRS complexes or miss the QRS complexes with reduced amplitudes. In normal adults, the heart rate is between 50 to 100 beats per minute. When it is more than 100 beats per minute, we call it as a tachycardia. When it is less than 50, we call it as a bradycardia. In children, the normal heartbeat is 110 to 150. For 2-year-old children, the normal heart rate is 85 to 125 beats per minute, and similarly for 4 years child it is 75 to 115 beats per minute, and for 6-year-old child it is between 60 to 100 beat per minute. Every life you touch is a seed of hope you plant in the world. With this, I conclude my today's topic. Thank you. Keep learning.